Hey everybody, so in this video we're going to talk about section 8.5, which is about solving rational equations. Okay, so here we have the steps for solving a rational equation. Okay, we are going to factor all the denominators, and the reason that we're doing that is to find the LCD. Okay, then we're going to multiply by the LCD on both sides, and this should clear away all of the denominators. That's the point of this method. Okay, once there's no more fractions, then you can finish solving the equation using whatever technique it requires. And we do need to check for extraneous solutions, and we'll talk about how to check for those quickly when we look at an example. Okay, so let's look at our first example. Okay. Now, if we look at this example, all the denominators are already factored, and we can see that the LCD is x plus 1. Okay, so I'm going to multiply the whole equation, both sides, by x plus 1. Okay, that means on the left side, I'm multiplying by x plus 1. For this term, I'm multiplying by x plus 1. And this term, I'm multiplying by x plus 1. Okay, so you're multiplying on the left and the right, and because the right has two terms, you've distributed the x plus 1. Okay, now I'm going to cancel out everything that cancels. So here this x plus 1 is going to cancel with this one, and I'll just be left with 2. Okay, here this x plus 1 cancels with this one, and I'm just left with x. Okay, and here I just have 1 times x plus 1, or x plus 1. Okay, now this is a normal linear equation, so I'm going to go ahead and add my like terms here. Subtract 1 from both sides. Okay, and then divide both sides by 2. Okay, so my candidate solution is x equals 1/2. Now, when I'm checking for extraneous solutions, I'm looking to see if that would make either of the denominators 0. Okay, if you put in 1/2, you'll have 1/2 plus 1, or 3/2, not 0. And the same here, you will have 1/2 plus 1, or 3/2. Okay, so this is a perfectly good solution. Okay, so for these types of equations, when you're checking for extraneous solutions, all you're checking is that it doesn't make the denominators 0. Okay, let's look at another example like that. Okay, so again, you can see that all the denominators are already factored, and we can see that the LCD is just x minus 3. Okay, so we're going to go ahead and multiply everything here by the LCD x minus 3. Okay, now in this term, the x minus 3 that we multiplied by is going to cancel the x minus 3 from the denominator, and we're going to be left with 5. Here we have this x minus 3 canceling with this one, and we're left with x plus 2. And here I have 3 times x minus 3. Okay, so I'm going to multiply this out. Okay, and I'm going to add up my like terms. So I have 4x minus 7. Okay, so now I'm going to finish solving this equation normally. I'm going to add 7 to both sides. and I'm going to divide both sides by 4. Okay. Now I'm going to check my solutions to make sure they're not extraneous. So when I'm plugging in x equals 3, okay, I can see that I would get 3 minus 3, or 0 in the denominator. We know that having 0 in the denominator makes the solution undefined, okay? So this is an extraneous solution, okay? And because our only candidate solution was extraneous, that means there are actually no solutions to this equation. Okay. So here's an example of what you see when you have an extraneous solution. You're checking it by plugging it into the original equation, and you can see that it makes the denominator 0. Okay. All right. Let's see another example. Okay, so the first thing I'm going to do is factor the denominators. So you can see the only denominator that factors is this one here, okay? So I'm going to factor that denominator. Okay, and when I look at the collection of factors, I can see that the LCD is 2 times x minus 2. Okay, so I'm going to multiply everywhere by that factor. Okay, so I'm going to have 2 times x minus 2. Here I'll have 2 times x minus 2, and here I'll have 2 times x minus 2. Okay, and now I'm going to cancel everything that cancels. So in the first term, the one on the left, I can see that x minus 2 is canceling with x minus 2, and I'm left with 2 times 3. Okay. The first term on the right side of the equation, this 2 cancels with this 2, and I'm left with 1 times x minus 2. Okay, and over here, the 2 cancels and the x minus 2 cancels. Okay, so I'm just left with 2x minus 7. Okay. 2 times 3 is 6. 1 times x minus 2 is x minus 2. Okay, and this is a regular linear equation, so I can solve this by combining my like terms. Okay, adding 9 to both sides, and dividing both sides by 3. Okay, I'm going to check for extraneous solutions. So when I look at my denominator, if I plug in 5, I get 5 minus 2, or 3. So this is not going to be 0. Here I'm going to get 5 minus 2, or 3 times 2, which is 6, also not 0. Okay, so because it doesn't make any of the denominators 0, this is a perfectly good solution. Okay. All right. Let's look at another example. Now, this is the type of example where students are kind of tricked by the LCD. Okay. Now, when you look at this, all of these denominators are already factored. So the LCD is just going to be the product of the factors. So 3x times 3x plus 1. Okay. So everywhere here, I'm going to multiply by the LCD. So I'm going to go ahead and write it out. I have 3x times 3x plus 1, okay, times the original factor, or the original term, which was 4 over 3x. Okay, then I have the LCD 3x times 3x plus 1 times the original term, which was 3 times 3x, 3 over 3x plus 1, okay, plus 3x times 3x plus 1 times the original term, which is 2, okay, equals 0 times the LCD 3x times 3x plus 1. Okay. All right. So now on the far left, we can see that the 3x is going to cancel with this 3x, and I'm going to be left with 3x plus 1 times 4. Okay. Here, the 3x plus 1 is going to cancel with the 3x plus 1, and I'm left with 3x times 3. Okay. Here, nothing cancels, so I'm left with 3x times 3x plus 1 times 2. Okay. And on this side, I have 3x times 3x plus 1 times 0, which is 0. Okay, so now I'm going to multiply everything out. 3x times 4 is 12x plus 4, okay, plus 9x, plus, okay, so now here I'm multiplying 6x times 3x, which is 18x squared, and then 6x times 1, which is 6x, equals 0. Okay, so here's my first one, my second one, and this third one. Okay, so now I'm going to write my terms in descending order and add my like terms together. So I have 18x squared, okay, then I have 12x plus 9x, which is 21x, plus 6x, which is 27x, okay, plus 4 equals 0. Okay, and now I need to solve this equation, right? This is an x squared type of equation, so I'm going to try to solve this by factoring, okay? So we're going to do this by factoring, okay? And you would do factoring by the guess and check method, okay? So you'll see if you do the guess and check method that this is going to be 6x plus 1 times 3x plus 4. Okay, now you can check 6x times 3x is 18x squared, 1 times 4 is 4, okay, 24 plus 3 is 27, okay. We'll set each factor equal to 0, okay, and then get one solution from each one. Okay. Now, again, when you plug these in to check them for extraneous solutions, you're only checking to see if they make the denominator 0. Okay, so if you look at this, the only thing that's going to make this denominator 0 is 0, and that's not one of our candidate solutions. Okay, that would give you -1/2, and this would give you +1/2. Okay, if we plug in -4/3, this would give you -4, and this would give you -3, right? Neither of which are 0. So both of these solutions are real solutions to this equation. They are not extraneous. Okay. All right. Let's look at another example. Oops. Okay, so the first thing I'm going to do is factor the denominators. This is the only denominator that factors. So I get 2 over x plus 1 plus 1 over 3 times x plus 1 equals 1 over 2 times 3. Okay, so that lets me see that the LCD is going to be the product of the unique factors, so 2 times 3 times x plus 1, right, or 6 times x plus 1. Okay, and I'm going to multiply each of these terms by that LCD. Okay, so here I'm going to multiply by 6 times x plus 1. Here I'm multiplying by 6 times x plus 1. And here I'm multiplying by 6 times x plus 1. Okay. Now, in the first term, this x plus 1 cancels with this one. So I'm left with 6 times 2. Okay. In the second one, this x plus 1 cancels with this x plus 1. This 3 cancels with the 3 in here. And I'm left with 2 times 1. Okay. And on the right side, I have this 6 canceling with this 6. So I'm left with 1 times x plus 1. Okay. So this gives me 12 plus 2 equals x plus 1, or 14 equals x plus 1. So x equals 13. Okay. Again, we're checking for extraneous solutions. You would get 13 plus 1, or 14, right? 13 times 3, which is 39, plus 3 is 42, still not 0, right? We're only checking to see if the denominator is 0. So this is a good solution. It's not extraneous. Okay. All right, let's see one last example of this solving method. Okay, so I'm going to go ahead and factor the denominator. I can see that this factors as the difference of squares. Okay, so looking at the 3 denominators, I can see that my LCD is the product of the factors, or 2x plus 3 times 2x minus 3. Okay, so now I'm going to multiply everywhere by my LCD. So I have 2x plus 3 times 2x minus 3. Here I have 2x plus 3 times 2x minus 3. Okay, and here I have 2x plus 3 times 2x minus 3. Okay, so I'm going to cancel out what cancels out. Okay, so in the first term, I have 2x minus 3 canceling with 2x minus 3. So I'm left with 2x plus 3 times 4. Okay. In the second term, I have 2x plus 3 cancels with 2x plus 3. 2x minus 3 cancels with 2x minus 3, and I'm just left with 4x. Okay, and then on the right side, I can see that my 2x plus 3 cancels with my 2x plus 3, and I'm just left with 1 times 2x minus 3. Okay, so now I'm going to multiply this out. I get 8x plus 12 plus 4x equals 2x minus 3. Okay, combine my like terms. Subtract 2x from both sides, and subtract 12 from both sides. Okay, and then divide both sides by 10. Okay, so now I'm going to look at my answer compared to my numerators. Okay, so I have negative 3 halves, Okay, so if you want to check plugging this in, right, I have 2 times negative 3 halves minus 3. Okay, so this is going to be negative 3 minus 3, which is negative 6. And that's fine, right, because it's not 0. Okay, so that was my first denominator, 2x minus 3. Then I'm going to check my denominator, 2x plus 3. Okay, so I have 2 times negative 3 halves minus 3. So this would be negative 3, oops, this is plus, okay, plus 3, which is 0, okay, and that's exactly what you don't want. So this answer, this candidate solution, makes this denominator 0, right? And because this has the same factor, it will also make this denominator 0, okay? So this solution is extraneous, okay? And because it was the only candidate solution, that means there are no solutions. Okay, so there's another example with no solutions. Okay, so that's the method of clearing denominators. I want to do one more example. I think that people are really familiar with this method, but I just want to make sure that you guys have seen an example like this. Okay, where you don't necessarily need that method. Okay. Okay, now this type of equation is called a proportion, where you just have one term on each side. If you look at all the other examples, we don't have a single term on each side, which is why we need to use the LCD method. Here, because we only have one term on each side, we can cross multiply. Okay, so we have x plus 1 times x plus 1, okay, equals 2 times 2x. So you can see that you are multiplying across the equals sign. Okay, this gives me x squared plus x plus x plus 1 equals 4x. All right, now because I have an x squared type of term, I'm going to move everything to one side and factor. Okay, so I have 2x minus 4x, or negative 2x. Okay, I'm going to factor this. So what multiplies to 1 and adds to negative 2, it should be negative 1 and negative 1. Okay, so because these two factors are the same, I'm only going to get one solution. It's a repeated solution. Okay, I get the solution x equals 1. Now when I check it, I plug in 1 to the denominator here, I get 2. That's fine. This denominator is already 2. So this is a good solution. It's not an extraneous solution. Okay. All right. So I hope that reminds you guys of how to do the cross multiplication method, and also instructs you guys on some more complicated examples where you're forced to use the LCD method to clear denominators. Okay, I will see you guys soon.